Why is molar heat capacity important in specific heat calculations? Imagine trying to compare how different materials heat up without knowing their size or weight. It would be like comparing apples and oranges. That's where molar heat capacity comes in. It helps us understand how much heat a substance needs to raise the temperature of 1 mole of it by 1 degree. Specific heat capacity tells us how much heat is needed to warm up 1 gram of a material by 1 degree. But materials can have very different molar masses, which makes direct comparisons tricky. For example, water and iron have very different masses per mole, so their specific heats alone don't tell the full story. Molar heat capacity takes the specific heat and multiplies it by the molar mass of the substance. This gives us a property that measures heat needed for 1 mole, regardless of the material's size. It becomes a more universal way to compare different substances. Using molar heat capacity makes calculations easier when working with chemical reactions or processes involving moles. For example, in the equation that relates heat, moles, and temperature change, the molar heat capacity is directly used. This simplifies understanding how much energy is involved in heating or cooling a substance. It also helps clarify how heat affects gases and other systems at constant pressure or volume. Knowing the molar heat capacity at constant pressure or constant volume gives insight into how much energy is needed to change the temperature under different conditions. In practical terms, molar heat capacity is essential for designing thermal systems, calculating energy in chemical reactions, and understanding how materials behave when heated or cooled. It connects the tiny world of molecules with the larger scale measurements we use every day. So, in simple words, molar heat capacity is important because it turns the specific heat from a mass-based measurement into a mole-based one. This makes heat calculations more accurate and meaningful when dealing with chemical quantities and thermodynamic processes.